Well, hello, everyone, and thank you for coming to this event in the Glowing Hot Topics in Cryptography series. Just some brief introductory remarks, and then we'll have a break, and then we'll start the roundtables at 11:15. Okay, people tend to be curious about TII, so I'm just going to fly through some information on the organization that we work for, and that is behind the Glowing Hot Topics series. The Technical Innovation Institute is based in Abu Dhabi in the United Arab Emirates. It's a big research organization with many different components. You can see the various sections here on post-quantum crypto research. That's what we do in the Cryptography Research Center. That's just one of the research centers. We have AI research centers and research centers covering other topics. Right, so you see we cover a lot of the hot areas in cryptography. And just to give you an idea of the scope of the organization, we have, I think, 95 employees from 34 countries, speaking 27 languages. So it really is it's like a United Nations out there. I think I'm actually possibly the only one of those 95 employees who only speaks one language. Right, I'm very impressed with the linguistic skills of my colleagues who speak multiple languages. So of the employees, rather less proud of the fact that there's 81% male and 19% female. That's something that we're continually attempting to address and improve on. We have 44 PhD students. We do rather better there on the gender split. And what? 44, yeah. Postdocs. Okay. We're very much into collaborations with other universities and other institutes, and we have active collaborations, as you can see over there, with various universities around Europe and indeed around the world. I would say with 95 people involved in cryptography, we're probably arguably amongst the larger crypto departments globally, right? So it's a good place to work if you're a cryptographer. Right, this is our team. You might recognize some of the people there. Hopefully you'll recognize me. And we have some KPIs there for your delectation. Right, we do a lot of publishing in a lot of crypto conferences. We're developing products. We're moving into IP and startups. So it's a dynamic scene. But that's where we are structurally at the moment. We have, as well as our resident team, we have a board of advisors. Right. Right. These are people who've given up their time to advise us on where we're going, what we're doing, where we're going next. And you'll probably recognize more names here, obviously. So it's a pretty strong team there, I think, who are backing us and giving us advice. Adi Shamir's name there stands out. I guess he was out with us recently, and he gave a very interesting talk on the intersection between AI and crypto. He was showing how a facial recognition system could be attacked so that one individual could be mistaken for another individual. Right? A very clever kind of the use of a cryptographic mindset, if you like, to attack an AI system. So that was interesting. We don't stint on the hardware. A lot of crypto is just purely software based. All you need is a laptop and a bit of maths in your head, and you're a cryptographer. But it's nice to do things in hardware as well. It's nice to personally, I love messing around with embedded systems, hardware, and we're very well supported there in terms of facilities and the latest equipment. So there's a picture to give you some idea of the setups we have for various side channel issues and that kind of thing. Right. Okay, the Glowing Hot Topics thing, this was an idea we had, and this is the second in the series. Last year, we had an affiliated event at Crypto last year, and that was on the subject of crypto agility, which was the hot topic of last year. And we judge that to be a successful event. I think you can still see it online. Very useful discussions took place. So that worked well. So this year we were thinking glowing hot topics in cryptography. I wonder what it will be. And I guess with the year that was in it, it really was what I think the Americans call a no-brainer. AI is all over the place. It's everywhere, and it intersects in a major way with cryptography, right? So we decided, naturally enough, that would make a suitable topic for this year. Right. Okay, so what are we doing today? When you think about the AI and crypto, you want to talk about it, you want to split it into various round tables. We have a lot of discussion internally as to how to structure that. Well, eventually we came up with the idea of three round tables. So it's a large subject. We're trying to break it up into three sections. So you put the next slide up. Yeah. Okay, so this is the program committee consists of myself, my colleagues Francisco and Victor, right? So we're the ones responsible for what you're going to see. What's going to happen today is, next slide, please. Okay, yep, this is the way we've structured the day. In part, there's a constraint in terms of the local organization, but we managed to fit, I think, quite nicely around that. We fit in our 4 round tables. The first round table, I'll be chairing it. That'll be on the general issue of crypto and the intersection with AI, what the issues are, what's going on, basically. That'll be at a kind of maybe a slightly higher level. The second round table will be chaired by my colleague, Francisco, and that'll be on the more established area of AI's application to cryptanalysis. This is actually a more mature area in a way, because cryptographers have been interested in AI and side-channel attacks, and using AI and deep learning methods to facilitate cryptanalysis. Right, so that's a kind of a more mature topic in the same area, general area. So we'll have a nice discussion on that on table 2. Then, of course, one of the huge worries with large language models and artificial intelligence in general is the implications for privacy, right? That's a hugely concerning area. So we think that deserves its own round table, and that'll be chaired by my colleague Victor Soukakis. Right, then we'll wrap it all up with a final session where we kind of bring it all together, have a chat. The people involved will be obviously the speakers on the stage, the moderators. We're just here to moderate, so we'll be standing back a bit. But you guys, we're hoping will get very actively involved. Hopefully, we get lots of questions from you. We've got a nice lineup of speakers here from a wide range of backgrounds. So whatever your concerns or worries are, or interests in this whole area, there should be someone up here who can answer your question. So please feel free to get involved. The individual moderators will indicate whether they'll encourage involvement during the course of the roundtable or whether, but there'll always be time left at the end for questions. So if you have questions, maybe formulate them now, and we'll certainly hopefully have time to address them. You'll get an expert response to whatever worries you. Right, so that's basically the structure for today. We're now have time for a break, right? And we'll reconvene and commence the first round table at 10:45. 10:45. Right, so that's it for now, and I'll see you in half an hour or so. Thank you. sure. Have a seat. Sorry? Yeah, just wait there. See if respond to what they say. Just lean forward to the Daniel. If something, let's say, happens, it doesn't stop the flow of
Hello. Hello. Can is it? Okay. Yeah.
Okay. Oh, wow, I got my very own. All right. I did, didn't I? She yelled at me.
Now I'm based in the US, but my team is initially from France. Okay. What do you do? Okay.
I'm going to ask you guys to introduce yourselves. It's very briefly. Name, affiliation, what their research.
By default, it's always on.
I don't know, actually.
Hello. Yeah.
I'm on. Okay, I think we're ready to begin.
Feedback about vision.
Okay, the etiquette around questions. If you have a question in the audience, I think the panelists and myself would be quite happy for you just to get involved immediately. There will be time at the end for questions, but if you want to interject, that I think we can accept that, and that would be fine. So if you have anything really pressing to say, feel free. But we want to get a discussion going here, obviously, a dynamic discussion between the panelists and with the audience. So that's the ideal of a roundtable like this. Okay, the subject of this first roundtable is the general issue of the intersection between cryptography and AI. And we're specifically interested to see what the various threats are. I was interested, I don't know if you guys get the cryptogram email from Bruce Schneier. It's a kind of security, he's a kind of security guru, and he has this monthly newsletter he sends around. And I noticed in last week's or last month's newsletter, he had 22 articles, and 12 of them involved AI, right? So, whereas if you went back 2 or 3 years ago, AI would hardly be mentioned at all. So AI is definitely big in the whole security side of things. And of course, AI gets hacked, and those are the dangers. So I hope you excuse me making just a few introductory remarks. What about the intersection between AI and cryptography? Well, here, there's a very good example. Recently, there's a project, I don't know if you've heard of it, called WorldCoin, right? Which is an AI meets crypto. This is according to Time Magazine, an AI meets crypto project. And it's from one of the founders of OpenAI, the guys behind ChatGPT. And it uses these orbs to scan people's eyes in exchange for a digital ID. And then they're rewarded with some free digital currency. Right, so there's an AI with crypto kind of intersection, a terrifying one, actually, with potentially terrifying implications. They hope to enroll everyone on the planet. And we can't deny blockchain is a child of cryptography. So AI and crypto are already interacting in strange and possibly dangerous and frightening ways. And when we're reading Bruce Schneier's articles, sometimes AI could look terrifying. Other times it could look ridiculous. He had this story that if you place a traffic cone on a self-drive car, it completely stops it from working, right? So it makes AI look stupid, you know. But more and more, I think where AI looks scary. So I was going to say that it's a bit like there's a hurricane heading our way, but then I thought there actually is a hurricane heading our way. So, but I think we have a lot to worry about. You guys, I've read a lot of your research. I've done my background reading on you. So in the hidden layers behind my neurons, I think I know a lot of what you know, but I don't really, of course. I know. So you guys are the experts, and we're going to be very dependent on you. We're all here to learn. Right. Okay. First, I'd like to ask our panel members if they just briefly introduce themselves, just so we know who they are. Could we start with Matthew?
Hey. Hi, everyone. I'm Matthew Jagelski. I'm a researcher at Google DeepMind. I sort of generally work on security and privacy of machine learning, including stuff like memorization and language models. Happy to have questions.
Hi, everyone. I am Daniel Wynn. I am the CEO of Security, which is a startup based in France and the US. We use secure hardware, secure enclave, and so on to provide integrity and confidentiality when you interact with AI systems. I guess I'll provide a more industrial point of view of those issues. And I hope I will provide some interesting insights.
Good morning, everyone. I'm Shivam Bhasin. I'm from Nanyang Technological University in Singapore. We are a team which is doing a lot of implementation attacks, which is side channel attacks and fault analysis. And since about 5-6 years, we're also looking at implementation security of AI when they're particularly implemented on embedded devices.
Hi, my name is Stjepan Picek. I'm associate professor at Radboud University, Netherlands. My research is mostly on intersection of AI and crypto. Mostly implementation attacks, so like side channel fault injection, and also quite a lot looking in the security of AI, so model stealing, backdoor attacks, and so on.
Okay, just to set the scene a bit, I was trying to find a quick, succinct way of summing up the issues here, and I found an interesting article actually from Shivam. Something he was involved in. There was a special issue on the transactions on intelligence technology on attacking and protecting artificial intelligence. So very briefly, modern artificial intelligence systems largely rely on advanced algorithms, including machine learning techniques such as deep learning. The research community has invested significant efforts in understanding these algorithms, optimally tuning them and improving their performance. But as most recently, it has mostly neglected the security facet of the problem. Recent attacks and exploits demonstrate that machine learning algorithms are susceptible to attacks targeting computer systems, including backdoors, hardware trojans, fault attacks, but are also susceptible to a range of attacks specifically targeting such as adversarial perturbations. Implementations of machine learning algorithms are often crucial proprietary assets for companies and thus are required to be protected. It follows that implementations of AI-based algorithms are an attractive target for piracy and illegitimate use, and as such, they need to be protected. Right. So I think that very nicely summarizes the situation that we're at. So first thing I'd like to do is go around the table and ask our panelists, what do you think the dangers are? How bad can this get? How vulnerable are these systems?
If I can start, I guess the question is exactly like, what do they do? And what is that risk with the solutions? For instance, we talk about LLMs and agents. And the thing is, yeah, you can poison the models at source. You can prompt inject the LLMs and so on. But the issue is like, what does it do? When an AI model says something, offensive, what are the actual implications and so on? And for instance, if you plug an LLM and allow it to execute code, of course, that's going to be bad. But why would you do that in the first place, And I guess the question is like, at the end, it's how do we use it? And based on that, we can make, actual claims about what is at risk and so on. And for instance, yeah, if your LLM only answers chat-related questions from your customers, and the output is text, and only humans read text, what is the worst that can happen? Well, your LLM can say maybe stuff about the data set if it was fine-tuned on your private data. For instance, if you're a bank, it can say offensive things, which is bad for PR. But if, for instance, we think about prompt injection, it's the person that actually, made the LLM say something bad. So is it an issue that an LLM says something bad if you provided a malicious input? Not exactly. Just like if you say something offensive to your bank counselor and he answers in a very aggressive manner, is the issue of the bank? No, you provided, malicious input. And so if the input is text and the output is text and nothing executed, the actual implications are often not that big. But if you then use the output of the LLM to actually have an impact on the world, like execute code, interact with APIs and so on, then it can be very dangerous. It can go like Skynet level of dangerous, but I guess it's also about what is use case, because there are a lot of interesting stuff that is going on. But if most of the use cases that we see is internal chats, like banks drops PDFs and get an answer in natural language, even if you poison the model, even if you do prompt injection, the worst thing that happens is that you have erroneous information outside.
Right. We get back to more detail on that. Matthew, what should we be worried about?
Yeah, I agree a lot that it comes down to what you end up using these systems for. I think sort of in the adversarial machine learning community, we've been kind of like, I feel like for the past, 5-10 years, just kind of tracking like, what's the scariest thing people seem to be wanting machine learning to do? And I think for a long time, this is like self-driving cars and stuff like this, facial recognition. And I think, of course, like everyone sees large language models and suddenly it's like, okay, like let's find what all these scary applications are. So, I mean, right now, yeah, a lot of it seems to be chat and that's not immediately like super scary, but like the kinds of things you can get out of models right now, it makes me a little bit worried about things that might be coming down the line that sort of aren't here right now.
So yeah, I mean, I totally agree with my co-panelists that security is an issue, and I would actually take a bit offbeat because normally we care about security much more when there is, for example, losses or commercial losses involved. So we do have like issues with safety and security of AI models, but that has always been there. the reason I think we should be worried now, or people will be worried because they are building business out of it. I don't have the correct statistics, but I mean, if I remember one of the recent news, OpenAI was, I think, one of the most downloaded app or most subscribed app that did some record of few hours up to 1 million user or something like that. And based on that, I think if you're building a business around it, you want your model to be secure. And I think this will, what will motivate people the most to think about security and will eventually like lead them to catch up.
Yeah, I agree with Shivam. I mean, looking at the security, cybersecurity, crypto and AI, there are so many possible attacks that people are constantly saying, well, let's do this attack, let's do that attack. And that's even not so surprising that we can attack in so many different ways, because realistically, machine learning was never designed to be resilient against things like that. The more question is that people now start to care about that because they're selling machine learning as a service, as a product. So there is definitely a huge surface how to attack. The bigger question is also to understand what attacks are really relevant to start protecting against those attacks. So I think there is still quite a huge gap between what academic community is doing, what we are attacking, and what industry is really caring about, what needs to be protected at the first.
Right. Okay. So we have a problem. we have a big problem. Right. So the next big question, I guess, especially for this audience, is what can crypto and what can cryptographers bring to the table? Like cryptography has been a kind of a standby technology in the security area. It's used to solve security problems. And in my reading, I noticed things were mentioned like that are well known to cryptographers, like multi-party computation, hardware modules, homomorphic encryption, watermarking, attestation, fingerprinting. Those things may be relevant. Countermeasures to side channel attacks, they may be of some relevance in the context of AI. So my next question to you all is, did I miss anything? And how do you think cryptographers can help?
Yeah, I mean, I think there's a lot of settings, like, I think a lot of these apply to sort of generic programs, like, things like, I don't remember specific examples, but like multi-party computation, for example, is something you could apply to any function, and the benefits that you get from that for any function are the same. I think there's a couple things that I think kind of specifically in the intersection between sort of security, privacy, machine learning, I think are kind of particularly interesting, maybe coming more from like a cryptographic way of thinking rather than specific cryptographic tools. So one thing I think cryptographers are like quite good with like definitions and assumptions, like more so than I think a lot of people in machine learning specifically, and sort of maybe more broadly in computer science. And I think that's something that's really, really nice, actually. Like there's a lot of these things that are kind of poorly defined, and I think that sort of there have been, okay, so for example, differential privacy is sort of an incredible sort of definition. It's a definition that's really taken a lot of hold in a number of places. It came from cryptographers back in 2006 and has really just taken off. And I don't think it's like an accident that it came out of like cryptographic sort of ways of thinking about the problems. And I think that we have a lot of situations like beyond just sort of specific these like privacy attacks, right? Like that was the goal of that was to protect against specific privacy attacks. And here we have a whole host of other attacks that maybe are amenable to some sort of like thinking about it in that's a similar sort of way. I think another thing is so I think there's sort of two ways to look at security, privacy, machine learning stuff. One is to sort of think about your model and what they're doing as like it's a human almost. Like think about it, it's learning, it's like use all these like really anthropomorphic words. And I think that's such a tempting thing to do right now because models are getting so similar to what humans kind of look like. But at the end of the day, it's a mathematical function, right? And I think we've seen a lot of really interesting research that comes from like ignoring the fact that it looks like a human, or like acts like a human in a lot. Like, so for example, like adversarial examples, and I think a lot of the like model extraction work, for example, is sort of just saying like, you're giving me a function, I'm going to do stuff with it, and like, let's see what can go wrong. I think that's something that a really like dedicated person with a cryptography background might be really suited to as well.
I think there are, well, so the question is also like always like, what do we want to achieve? And for instance, I think cryptography is very good for what I like to call input privacy, which means, for instance, I'm a bank, I want to use OpenAI. I don't want to deploy their model inside my infrastructure because it's too complex, but I don't want them to see my data. And I guess, homomorphic encryption, MPC, secure hardware, and so on can provide input privacy, which is I use their service, I use their APIs, but I try to not trace them as much as possible by using cryptography to protect the privacy of my data. So that's where one aspect where it makes a lot of sense, because it's very unlikely that people will deploy GPT-4 either on their mobile or on their data center. And it makes a lot of sense to centralize compute to run those GPT-4 models, but at the same time, you don't want to have OpenAI see all of our data. And therefore, using cryptography to protect the privacy of the inputs is quite interesting. I guess there is also another issue, which is there will be more and more LLM-generated content out there. And then there is the issue of what does the information come from? And here we can use, blockchains and signatures to say, okay, this piece of news comes from the New York Times, for instance, and they sign it with their own keys. And I guess it's about traceability of information. And I guess it will be important because there'll be more and more, AI-generated content. And so I guess one of the interesting ways is to use cryptography to provide provenance of information. And finally, there is one interesting thing where crypto can be interesting is having provenance of AI models. Today, AI models are just equivalent of executables. And for instance, there are a lot of open source models you can download from Hugging Face, but using those is the equivalent of executing an unknown binary. You don't know where it comes from. And that can be a big issue, especially if you allow the LLM to take decisions for you. Like for instance, you can say, oh, I can use that LLM for code generation and execute code, so on. But then you don't know what comes from. It might have backdoors. And therefore, there can be a big issues of using LLMs for your workflow. But you can have solutions to provide integrity of provide proof that, for instance, a specific piece of code and specific data sets are used for the training of an AI model, and therefore have more trust in an AI model. And today you have no provenance at all. Tomorrow I could drop a model on a Hugging Face with a backdoor, and as long as it's good on the leaderboard, many people can use it, and I can put the backdoor that is used by many people. And today, there is nothing at all to have provenance of AI models, but we can have solutions based on cryptographic solutions.
So actually, I think that cryptographers are already active in this community, and they're already helping. So if we look at crypto, for example, a couple of years down the line, there were some papers which have been published on how to attack AI. We have also seen like a lot of security constructs about AI coming from them. So we have FHE, we have MPCSS. It was already mentioned, and these are like tools which are actually providing some much required security guarantees that we need to actually secure AI. One particular direction which I'm very interested in, and actually I would encourage cryptographers to look into, is that like I've recently started looking into formally proven models. So for example, like you can take a model which is probably giving you a performance of an accuracy of 90-something%, right? The moment you want to guarantee some like a formal guarantee towards adversarial attacks or fault attacks or something, the accuracy drops to like 33%. And like, there's a huge gap between them, like 60-70% of accuracy. So I think like cryptographers definitely have a role to fill this gap where we can actually probably approach a model that is high accuracy as well as can provide formal guarantee at the same time.
Yeah, being the last in the panel, I always need to say I agree with the colleagues. I agree with Shivam. Indeed, what we have today is, from one side, we as cryptographers are quite well equipped to address a lot of threats for AI, because whatever, I mean, it's a function. In the end, we don't care, is it AES or is it a machine learning algorithm? So you know the basic principle, how you can protect it. And people are indeed doing a lot, reusing techniques, like Michael mentioned, I don't know, attacking on, then masking something, masking your machine learning algorithm so that it becomes more difficult to attack it. So that's all things that are people doing, and we kind of know how to do it in a good way. What I do see as a still open problem is that we as crypto people, we obviously do not know as much about AI as hardcore AI people. So you could still see quite a big gap when you are trying to make system more protected from the crypto perspective, that you don't necessarily know what is the most important part of the algorithm machine learning model to protect. So then you see this, then you see that. It's the same like in crypto. Would you mask all your rounds, or would you mask, I don't know, beginning end routes? So the same question comes to machine learning models. Would you mask your activation functions? Would you concentrate on the last layers? Would you concentrate on the first layers? So there are questions that are still not clear, especially for people that do not have necessarily expertise in understanding what each of those layers in machine learning model actually does and how does it do.
Yeah. Hey, as well as trying to protect these systems from attack, I guess the other thing we might look to for some hope would be in the area of regulation. I think, Daniel, you can enlighten us a little bit about what the current status is as regards the regulatory scene. Any hope there?
Interesting thing I just saw recently is, I think there was a ruling that says that content generated by AI is not submitted to copyrights. That's an interesting thing. I have to check. I just saw that this morning. As you know, there's also like the EU AI Act that is coming and so on. But the truth is, they are not technical at all. It's like, okay, you should document. Okay, but we both know that, I mean, between what I show and what I do, there's a huge gap. I can say something or not do it. But the issue is, most of the regulators are not technical. Do they know about, integrity of code, integrity of data, and so on? Not always. And I see a big gap between, what we know as experts about what can be used if we're not precise enough, and what the regulators actually demand. And it's a bit frightening because if this is the level of things we need to provide to have a high level of security in general, this is what regulation demands of people. And if regulation is not demanding enough, then we'll always keep at this level, and there will be a whole set of attacks that will be performed, often without our knowledge, just because the regulators did not, listen to people like us. And the thing is, it's not hypothetical. I mean, those attacks can happen. Like, we just saw, for instance, that, I mean, it's not even an attack. The funny thing is, for instance, Samsung suffered from a data leakage, and it was really stupid. It's simply AI models learned by heart the data that they're sent to. And it was not even malicious from OpenAI. I don't know if you heard about it, but basically, end of 22, engineers from Samsung put production data inside LLMs, and OpenAI learned by heart the data, and someone else got it out. So this is what we call output privacy. But that's very interesting to LLMs. And the issue is, it's very hard to prevent. You need to think about that. And people talk about what they want to see, but never about how can we define standards to actually achieve those goals? And regulation is never about, I mean, on my humble and young experience about that.
I guess regulation is coming, but we don't hold out too much hope in the short term. I guess, yeah, sure, jump in.
I don't know that you can say anything in a law like that is actually like a technical specification. I think, I mean, there's going to be better and better techniques developed. Like, I think any research can always be improved, you know, once you put it out there. And so I don't know if you can actually just say like, okay, you know, this is X, Y, Z. Yeah, maybe that's a lower bound, but
I think the truth would be we need to have industry leaders that create the standards that then inspire regulation. And that's what happens. And it takes a lot of time. It takes a lot of time and it's complicated. I think that's the most likely thing and positive thing that will happen is like, I don't know, researchers, GAFAM, etc., define the standards and those can be then seen as state of the art and incorporated into regulation, but it will take a lot of time.
I agree. But with AI and security of AI, I think there is another additional, let's say, problem that the domain is so active. I mean, when you compare it with crypto, I mean, in crypto, you have some group of people doing something, and then if there is like 100 people doing it on the world level, you will say, wow, that's a lot of people. In security of AI, there are thousands and thousands and thousands of papers every year happening all the time, new types of attacks. Of course, every paper to be published basically says, well, mine is the best attack, mine is the best defense. So it's also very difficult, in my opinion, for any kind of regulation to follow this kind of mass of development where realistically, probably a huge part of that development is really not important, but it's very difficult to recognize what is important.
So, Shivam?
Yeah, actually, in Singapore, we recently published a document towards security of AI, security and privacy of AI. And after looking at the document, like I would say, like we can only come up with some recommendations. Like policy making, I think it's way too far from that. So we have this document which gives you a bit of guidelines on what attacks would take care of and basically a set of nomenclature, but it is only at the recommendation stage. I think we are too far from any policy making.
I guess if regulation isn't maybe going to come riding to the rescue, so in a sense, we have to put our trust in maybe in big tech, because big tech are going to be our team to roll this stuff out in a competitive sense. So a rather unfair question for Matthew. So what's the feeling inside Google? What's the sense of awareness? What's the sense of responsibility? What's the sense of what are you guys going to do? Or can you self-regulate?
I think that we're doing fantastic things. I mean, yeah, like of course I can't say anything like specifics, but
no,
you know, like I think that the entire community, the entire sort of space right now is a little bit of a mess, because no one sort of really knows exactly even how to evaluate these models in terms of things like security. Like, I think that we've had attacks like traditionally on models that are so much less capable, and now you sort of need to, you know, update everything you know, like essentially, like for example, in privacy, people have focused so much on a very specific, very easy kind of attack known as membership inference. And suddenly you start training large language models, and it turns out they'll just spit out their training data. Like, this is a much more real threat than a membership inference attack, or it's a much more blatant violation of privacy. And I think that, you know, at Google, of course, we're doing a lot of research into this and sort of into all these sort of topics of safety. And of course, like there's a lot of work going on in making sure that the systems are, safe up to some level, but like at the end of the day, like the attacks are just going to get so much better, I'm sure, like over the next year or two. Like, so, yeah, I mean, of course, I think that we're, one of the best places in the world for this. I think we've got a lot of really top-notch researchers, but like, it's, if you've got 1 billion people using their system, it's hard to compete as a security like tester, for example, with just that sort of scale.
Daniel, can I ask you? You're kind of on the cutting edge of the industry. Are you have, I'd like maybe if you have a few war stories. Can you scare us all to death with things that can happen and things that are going to happen?
As I said, for instance, the Samsung event is a very interesting one, and I think it will continue happening because, as we said, a lot of LLMs by default, I think, is to learn by heart. It's literally the things they're trained to do. So of course, there will be output privacy issues, which means LLMs splitting the data out. And people don't understand that. When you look at stuff on the internet, they say, here is how I can fine-tune an LLM. Don't fine-tune your LLMs unless you're very aware that there is a privacy issue. Because when you do that, the model is very likely to say data that was trained on to outside people. What does that mean? We hear a lot of people saying, oh yeah, I will do, let's say, an LLM that answers, questions of my customers. I discussed, for instance, with a Fortune 500 company that works with beauty products. And they want to say, okay, I'm going to fine-tune my LLM on Q&A that I have in the past. But it's very confidential information. Like some people say, oh yeah, I have that kind of skin issue and so on. And what happens if you fine-tune on that data? Well, tomorrow, if I use their app, then there's a very high chance I make the app spit data out of people who are discussing with the LLM. And this is very, very likely. As I said, it's not like membership in France. Like AI models are literally trained to do that. And it's not a question of if and when, and it already happens with Samsung. And we're not saying more because people are not good enough yet to fine-tune their models. But when it will be done at scale, you're very likely to see these events happening all the time. And yeah, so that's why, there is a very possible, very likely chance that we'll see a lot of data leakage because of training the AI models. And this is not an issue of crypto or whatever, it's just LLMs, how they work internally, learn by heart. So.
Right. Maybe now we can drill down a little deeper into your own individual research and what you've been looking at. Shivam, could you tell us about maybe what you've been up to in reverse engineering neural networks, especially with fault attacks and doing exciting things like shooting lasers at embedded systems? Like, what results have you been getting? What have you been finding?
So I actually got involved into this research when we were trying to test some of the AI models running on embedded devices. And we actually got some very interesting insights because like what we see now on an AI device is essentially what the chess community saw like 20 years ago when they were deploying cryptography on an embedded devices. So since of course they don't have any protection, like you have like deep-rooted problems of side channel attacks, you have deep-rooted problems of fault attack, as well as like other physical attacks that we typically know. Now, we do, let's say, have some set of benefit from there. Like, I mean, it's not as easy to attack as for example, we attack AES or ASCON, for example. But like, there are definitely like leakages which can be exploited. Now, if I talk about the landscape of the attack, when we started this work, we were doing it on simple microcontrollers. Now, these are considered to be quite easy target when we're doing. But over the years, we have expanded it to FPGAs, we have expanded it to GPUs, we have expanded it to like also commercial AI devices available from like Google or Intel. And actually, what we found out was like you really have to like tag what is more important to you. So let's say if you just want to learn the architecture of the target model, that is scary. Like even on a very complex device, like a GPU or something, which typically is considered to be hard, a single trace is enough to actually learn the architecture altogether. Now, when we go deeper, if we want to learn the weights, biases, etc., maybe it is like something you can be a bit more relaxed. The attacks are possible, definitely possible, but it requires effort. But like if it is only the architecture that you're trying to secure, you definitely need countermeasures down there. Now, considering fault attack, actually, so this is more of my personal thing rather than something which I can actually formally prove. I see a very strong correspondence between fault attacks and adversarial attacks. It's basically you're doing an adversarial attack when you're trying to shoot in lasers. What you're basically have the power now is like instead of just controlling the input, you have the power to go deep into your model and target any particular computation, and therefore like the implications can be very strong. So I think like if we can try to formally combine these two approaches, the one countermeasure can actually work for the other one as well.
Yeah, okay. A question for Matthew. I was reading some of your papers, and I was alarmed to discover, as a layperson, my understanding of these systems is that the training data goes in, then it kind of gets mushed up and it gets tucked away in the hidden layers, and the training data is subsequently dispensed with. What you've discovered is that that's not in part what's happening, that these models are actually retaining information. They're actually memorizing. Could you just maybe tell us your experience of that? And because that's not what we expect.
Yeah, well, I mean, I guess it depends on who you're asking to expect something. But I mean, I think if you sort of talk to ChatGPT or Bard or Cloud or whatever, yeah, I mean, like they really feel like they're interacting with something that isn't just reciting its training data. And I guess, yeah, what we saw in the sort of attacking GPT-2 paper is that, you know, you can just prompt it with stuff from the web. You have to be a little bit, and sort of just get it to start talking, you know, like get it to generate a bunch of stuff. And, you know, if you can be a little bit clever about how you sort of filter things, it turns out you can pretty reliably identify examples that it's just spat out that were training data. So, you know, it'll learn things like links, and we had this like really cute example. It's our like figure 1 in the paper. And it's like, it's one person's like personal information. You know, you can see like the email, the address and everything. And like, we wanted to get this person's permission to actually put them as our figure 1. And like, so we emailed the address that GPT-2 gave us. It's pretty cute. But yeah, like they do this stuff, and it's also this question of like, what are you using these models for? What are you training them on? And sort of the more sensitive the data that you do start training them on, the scarier the stuff.
Yeah. So you give one thing that can be extracted is things like passwords.
If you make the really poor decision to train on passwords, yes.
Okay. You have this thing called, maybe we can talk about poisoning attacks, but maybe our audience isn't too aware of what a poisoning attack is and how dangerous that is. Anyone want to take off on that? Just listen. Stefan, yeah, go on.
So yeah, so poisoning attacks are basic attacks where you poison your machine learning so that it misclassifies so whatever the goal is. And I mean, it's quite, I would say today is probably even the most active threat. Most people are interested in poisoning attacks. And then you have different types of poisoning attacks. There's the data poisoning, where you actually change something in the data, or is modular poisoning, or is code poisoning. I feel that threat is quite interesting in general, poisoning attacks, especially backdoor attacks. But again, the main question remains what would industry think about it? Again, you can do what attack-wise, depending on the threat model, you can do whatever you want. But the point is, how much industry would you actually worried about poisoning attacks beyond saying, well, look, I poisoned 20% of the data set, and that's why you misclassify dogs as cats or something like that. There is definitely a huge threat setup, but the question is how exactly use it in a very practical scenarios and connecting to it with crypto. I mean, how can we poison? Then definitely something like fault injection attacks could be a very interesting way maybe to play with the code, with the model itself. So there is an option to do that. I don't know that many people are actually, there was Shivam's paper a couple of years ago, but more than that, but that was basic inference attack. So going to the later phase, but the same concept should be valid also for poisoning, for training time. I definitely feel there is a lot of work to be done and being done at the moment about poisoning attacks as the main threat. The attacks happening in the inference phase or something like adversarial examples, at least it's already seen out of fashion, like 4 or 5 years ago, everyone was doing that. Now, less people are interested in that. Most people are interested in attacks happening in the training phase and connected with poisoning attacks, also possibly sponge attacks, where you don't necessarily require your algorithm to misclassify or whatever, but you just want to increase the energy consumption or latency of your algorithm, which again brings new types of threats. So the surface is quite interesting there for sure.
Matthew?
Yeah, and I think one thing that's kind of tricky here, like in general, if you think about the problem of poisoning as you've manipulated the weights of a network or something, or you change training data, is like for a lot of goals for an adversary here, we just don't know anything to sort of protect against this. I am happy to state, and I would love to be thought on this, that we have no good protections for poisoning right now. And I think this is a really interesting problem. And part of this is because the potential goals of an adversary are so broad. You know, like you can't exactly like do, even if you had access to all of the training data, I don't believe that if you had a 10 gigabyte data set, like you could reliably identify what if that is poisoning or if there's any poisoning in there at all. The only thing I really think you could do is just have a training data set that's perfectly clean. But I would love to be thought on this if anyone has different opinions.
Yeah, I kind of agree and disagree at the same time. Yes, I mean, having the clean data set would be a beautiful solution, but is it realistic? And then still, it's only covering data poisoning. It's still not covering model poisoning or code poisoning aspects. So what I feel is a huge problem is that there are so many different poisoning attacks happening all the time. I mean, academically happening all the time. And there are so many defenses. And then, there is a paper saying, well, this is the best attack. There is a paper saying this is the best defense. But it's very difficult to know what would actually some defense really do against all possible attacks. And what can you then do? Really implement all possible defenses. And there is also the perspective that no one really follows that defense side to really implement the algorithms. You say, well, look, I have a beautiful defense. It will protect. If you ever try really to implement it on an embedded device or anything, and would it even work? We recently played with some defenses, really putting on embedded. It's very difficult to make the device sometimes even work because the defenses do work, but are very expensive. And then once you start putting all that on something that's not meant for something so expensive, then it's a problem. Then, maybe you would even say, well, I do have defenses, but you still need to say, well, I cannot implement. So there is a problem also there.
I would like to, state a few things, some of my opinions. I think the strength of AI models, its foundational model is that they are trained on very large corpus of data on the internet, on Wikipedia and so on. And that's how they're good. But that's how it's easy to put some malicious data points because, it's very, you you can put malicious data on Wikipedia just before, they scrap it, and then you inject, poisonous data and so on. So I think it's very unlikely that we'll say, okay, no, actually, I'm going to create a very good data set of 10,000 tokens. I mean, this is unlikely. The strength of these models comes from using large, very large data sets, but that's also how it's, the larger it is, the easier it is to poison it. But so I don't think we will have a clean data set approach, because that's not, and actually having very large and noisy data can be good for, robustness of models. So yeah, I think we'll always have those very large source data sets that most likely will be poisoned. But then the thing is, then it's about like making sure that those weights are most of the time doing things that are interesting, or at least not a poison and so on. And so I think one area where cryptographers could work with is maybe people who work on explainability, because then it's about how do I know that these weights encode good behavior? And this is very specific to AI. So it's really about, maybe making those two fields talk more, the security, and also people who just want the AI models to, be aligned and so on. But alignment is also like not, for instance, misclassifying things or hiding backdoors and so on. So I think the tool that exists to, see what happens under the hood, as like what they're working on, I guess, at Google and so on, for the explainability/alignment stuff, can be used to also make the output of the LLMs potentially safer and more secure.
Yeah, so I guess we sort of all seem to agree that you're not going to have a perfect clean data set. But I think I remember some mentions of data provenance, sort of being able to like prove that you train on a specific data set. If you are never going to have a clean data set, then what is the point of data provenance?
I think the problem is you will have a part of the data set that is clean, but how big is that? I mean, also let's not think only about centralized machine learning where you are maybe a little bit more powerful. Let's think about decentralized setups like federated learning. Federated learning, then it's very tricky to enforce, if there's thousands of users that none of the users is malicious. And then the question is, okay, if there is one malicious client, how big of a threat is that versus 10 versus, so indeed, with data provenance, you can do a lot, but you still, I mean, there are papers say, well, you just need a part of a data set that is clean, and then on that data set you do some checks, and then you get more security, and all that is nice. But again, it's a trade-off. On one side, yeah, if you have everything clean and closed and the system is perfect, yes, that would be great, but that also sounds very much not widely usable, because there are guards guarding your model. So yeah, no one cares about poisoning attack because no one can access it. But once you deploy your model to a wider audience, to many people that they want to tune their models for their own usages, I think relying on anything is very tricky.
That sounds like going into the direction of blockchain.
Yeah, I think that there's something that we don't talk about, like who do we trust in this whole ecosystem? And I think the truth is, one way to kind of to find the middle ground is to say, like the big tech companies are more or less trusted in the sense that Meta just released Llama 2, and I guess people will trust it. Like we don't know where, we don't know what data set was used, but people more or less at least trust it. And also having at least an entity behind it and having it open source still disincentivizes them to put in their own data set and release a model that people could, analyze and see if there is something malicious. So I guess we can more or less say the large training set and so on, it's responsibility of like the biggest foundational model providers such as Meta, Google, and so on to take care of that. And if they release a model and it was poisoned, people will see that, and therefore you have a kind of, responsibility. But to me, the issue is more like a lot of people can then fine-tune those models, and at that moment put a small but potentially very poisoned data set, and then other people will use it. So my point is that, yeah, to me, you would more or less trust the foundational based models. You have no way to expect that training set and so on. But the real issue is all the potential people who would take those models and fine-tune them with potentially poisoned data. And that's where data provenance can come in and say, okay, actually this model is derived from Llama 2. And then the question is, what algorithm did you use and what data did you use? And all those people that publish on Hugging Face and so on, potentially could poison the whole platforms. So we can imagine in the future that, okay, we can still try to hold accountable, and we will do meta and so on, but the riskiest and potentially most likely thing to do is to make sure that the people who derive those models and then redistribute them actually did not include backdoors in their models. Because, yeah, there are a lot of people who fine-tune Llama 2 on small data sets. We don't know what they do. They just say it's Llama 2 70B fine-tuned on whatever. And then they have a better score than Llama 2 from Meta. And then they are likely to be used a lot. But those guys don't know who they are, what they did. They have no papers, they have nothing. And I think, to me, that's the part that can be potentially dangerous. But in that case, because you can potentially just fine-tune on a small data set or so on, then for that specific use case, you can potentially have provenance.
So I guess there's one thing. I don't necessarily trust Llama 2 just because I trust Meta, because it's trained on, internet data, right? And so you also do have to trust the entire internet data that it's been collected on. I guess the other thing, maybe it's just because I'm not really a cryptographer, and so I don't know what specific guarantees you can get from provenance, but there's a lot of sort of non-determinism in training. And, you could say, okay, I'm going to fix the seed, start from the exact model. I'm going to, prove that I used this exact training order and everything. But if the second your model touches a GPU, that's all out the window. Like you can, the sort of order that a GPU does, additions, it sort of combines things. That's non-deterministic. And a long time ago, I sort of trained a model on fashion and mist, or trained two models on fashion and mist. And what you do is you fix the initialization, you fix the sort of data order that it sees. And at the end of training, just because sort of these errors in GPU sort of propagate, back and forward and backward, it made different predictions on 10% of its test data. This is like a reasonable model, but 10% of its predictions are completely different. And what this tells me is that if you wanted to have like a notion of provenance, it would need to be specific to CPU training, like single threaded. And so I'm just curious what.
Regarding the first point, if you say that you don't trust Llama 2 because it's trained on the whole internet, I guess you wouldn't trust also the models that you have from Google and DeepMind because you also use, I guess, those large data sets. So that's the first point. And the second point is there are methods that provide provenance, but not reproducibility. Because I guess that's what you have in mind is if I want to know where the data comes from, I can just reuse the same code and data and see if I get the same thing. And I agree, because of the non-determinism and simply cost, it's not going to be likely to happen. Because, for instance, if I want to know that Llama 2 comes from that data set, do I have to rerun Meta's training procedure to just get the same model? And as we said, it's very unlikely. But there are other methods to have traceability and not reproducibility, which is a weaker notion, but it's much more easier to get is, for instance, to use secure hardware. That's something we have explored, which is to use TPMs to get the hash of the code that is used on every artifact, especially the hash of the training set. And then you get an output, which is the weights of the model, and you can create a cryptographic proof that the specific weights were derived from applying the specific code to that specific data set. This will not be reproducible, but at least it's traceable. and you can sign this whole thing and have proved that, yeah, this model was a result of that. And this way you can have actually provenance of data with strong
Yeah,
guarantees.
very quickly, I just want to leave time for questions. I've been a bit remiss in that regard. Quickly.
Like guarantee hashes on poison data, right? Because you're receiving the data as
Yeah,
poison,
so
right?
it's all about accountability. You can know that this specific data set was used. At the moment you do that, you don't know if it's poison or not. But it disincentivizes people to use poison data because at any time I can say, okay, show me the data that was used, show me the data that is linked to that hash, and any auditor can say, actually, that data point is weird, and therefore you hold people accountable now. It doesn't prevent people from causing data sets, but at least people who train models are now accountable because you can store that proof on, let's say, on a public ledger or whatever, and at any time someone can come in and say, show me the data, and therefore you're not incentivized at all to put poison data.
I'm afraid, as often happens, the debate kicks off just as the clock runs down. So I don't know, Stefan, you want to quickly jump in?
Yes, so in my opinion, the problem is there are so many different ways how to use and settings where you use machine learning. So trying to put everything into one umbrella, it's very difficult. So we should always discuss worst case scenario, and then that's helping.
Okay, I need to open it up. Questions? Have we any questions? Amanda might have some. There's a question over here. Just throw the mic around. Sorry, we may overrun here a bit.
Thank you. Great discussion. So I have a quick question about, it's perhaps related a bit to poisoning. So let's say that a model is using some data that the user didn't consent to. So that data is being leaked and it's forever learned, and the user doesn't agree with that. So they sue the company and so on and so forth. So is there any way of getting rid of that data without retraining the whole model? Because once it's learned, so I want to get it out of the system. So is there any concept of like differential learning or something of this sort? Thank you.
Yeah, so there's a field known as machine unlearning, which sort of hopes to get this. The tricky thing is, there's like compute constraints, and there's a question of like, what does that actually mean? Like to actually, you would want like the model to look like it had never seen that data, like, to look exactly like that. But like, there's a number of ways where you could sort of like define this essentially. And it's tricky. I don't know if anything's actually shelf stable right now.
I think it's a form of lobotomy of LLMs. And the thing is, as long as as soon as it's used, you have no way to, it's just like the knowledge is diffused in the weights. It's very hard to identify which weights are responsible for storing information about that person and removing it. So I think this field is interesting. I think it's necessary, but it's not sufficient. And to me, the best prevention is simply, if someone does not agree, prove that it's not used for training. Because if it's not used for training, then there's no issue. But it's more about, I think the biggest answer is integrity. Like, how do I know that OpenAI, when they say they're not using it for fine-tuning, actually use that? That's what we need to do.
Okay. Just to add, like, if you're looking at a particular set of examples, I think there has been a lot of work which is done on fairness, where you look for, let's say, natural poison from the past and then trying to overcome in the models. I think some of those techniques can be easily used.
Yeah, I'm afraid I have to call a halt. I'm sorry I got it a bit wrong there on the time for a question. There is a last session, however, table 4, where we're going to revisit all of this, and I promise that there'll be more possibilities there if you have a burning question. So I think we have to make way now for the second round table. So I'd like to thank everyone in the audience and everyone on the panel, and thank you for.